Hello students, welcome back to our channel Physics Gallery. Asha Vinu. This is your Asha teacher coming with a new question from our electric charges and electric field. Okay, so the question given is that 2 point charges plus q and minus 9q are separated by a distance of d apart in free space. Find a point on the line joining the two charges where a third charge capital Q placed will be in equilibrium. Equilibrium means the net force acting on the system will be zero. Okay, so what about the system? The system consisting of two charges plus q and minus 9q. So we will draw like this: plus q minus 9q separated by a distance of d in free space, isn't it? Okay, so if we draw a line, that is, this is the line, and if we extend that line, the line will be like this. Okay, in this line, there is a point where the net force becomes zero. Equilibrium means net force is zero. So we can take a point in between the two charges, left of plus q, right of minus 9q. Okay, at first we will try to take a point charge a point in between these two charges. Okay, suppose a point P is taken in between the two charges and we have put capital Q there. Now the charges are minus q, plus q and minus 9q are unlike charges. So they shows other type of force. So we will look on the force from different types of force. Okay, so we will look on plus q. The force provided by plus q on this capital Q will be repulsion. So plus q tries to repel capital Q away from it. So it will be towards the right. Similarly, minus 9q tries to attract plus q because they are unlike charges. Unlike charges will attract each other. So minus 9q tries to attract plus q. So attraction towards itself. What happens to the direction of the two force provided by the two charges on capital Q? They are in same direction. So whether they cancels out, never. That means for a point in between the two charges, there will be not at all a condition where we get an equilibrium. That is, the net force acting on the charge will be zero. Okay, so we will go to the next point. So we can take this point. This point is wrong. You have to cancel this point. Okay. Now, consider a point nearer to plus q outside the line. Okay. So, at this point P, if we place the capital Q, what happens? Plus q repels it. Plus q is kept nearer to this capital Q and it repels capital Q towards the left. Whereas minus 9q, which is away from this charge, a long distance charge, it tries to attract. So the force will be towards the right. So there is a possibility for net force to be zero because the direction of force acting on capital Q is opposite. Okay. And if the magnitude is equal, then it will be correct. And if I take a point P right of minus 9q, which is also outside the line joining the two charges, then what happens? Minus 9q, the large charge, tries to attract q towards itself. At the same time, plus q, which is a small charge, tries to repel capital Q away from it. So the direction is opposite. But whether they cancels out, direction opposite, but whether their magnitude becomes same, never. Why? The larger charge is trying to pull capital Q towards it from a nearer point, and a smaller charge is trying to pull capital Q away from it from a larger distance. So a smaller charge at a larger distance, whether it cancels the larger charge at a nearer distance, the force provided by the smaller charge will be small and the distance is also large, then it again becomes smaller. Whereas the force provided by the larger charge is large and it is nearer. So the larger force is, there will be a large force provided by minus 9q, which can never be cancelled by a smaller charge at a larger distance. So here the direction is opposite, but magnitude will never be equal. So force cannot be zero there. So that point is also not an equilibrium. Okay. Now, if we consider the point P nearer to plus q, what happens? Smaller charges is nearby, whereas larger charge is far away from the capital Q. So what happens? Yes, there is a possibility for what? Smaller charge produces small force from nearby, okay, but the force is from nearby position, and a large charge produces less force from large distance. So in this case, the force provided by plus Q, small charge in the near point, will be cancelled by the force provided by a large charge from a larger distance. So this is the only point where there will be a condition equilibrium. That means if we take two unlike charges, always equilibrium will be obtained nearer to the smaller charge. Okay, outside. So for unlike charges, okay, for unlike charges, the force will be 0. My pen is over, sorry. The force will be 0 only nearer to the smaller charge. Outside it. Okay, clear? Is it clear? That is, we can take once more the plus Q, minus Q, 9Q. This distance is D, isn't it? Yes, this distance is D, and here a point P where capital Q kept at a distance x. Okay, the force will be 0 only at this point. Force F is 0 only nearer to the smaller charge outside it. Okay. Okay, so we understood that if the charges are unlike, always the equilibrium will be nearer to the smaller charge outside the line. Okay. So we will take the point like this. This is the point where capital Q experiences no force. Plus Q will repel like this, and minus Q will attract the charge like this. Isn't it clear? So we can write, if this distance is x, plus Q is at a distance x from capital Q, and minus 9Q is at a distance D plus x from the capital Q. Okay. So the direction is opposite. Now we are going to take the modulus. Capital Q, the force acting on capital Q, small q, is equal to the force acting on capital Q due to minus 9Q. Clear? 1 by 4 pi epsilon 0 is written as K. So K, capital Q, small q by the distance is x square equal to K, capital Q. We never put the negative sign of the charge when we take the magnitude of force. So take 9Q by what is the total distance? D plus x, the whole square. Cancelling K, capital Q, small q. We will get 1 by x square is equal to 9 by D plus x, the whole square. Taking the square roots, we will get 1 by x is equal to 9 by D plus x. Sorry, 9. Square root of 9 is 3. Cross multiplying, D plus x is equal to 3x. Okay, and D is equal to 3x minus x, which is equal to 2x. Therefore, x will be equal to D by 2. Is it clear? So, we will get a force which is equal to 0 on capital Q. The charge of Q will be in equilibrium at a distance D by 2 from small q. And if we have an option like this, at a distance minus 9, at a distance, some distance from minus 9Q, that means D plus x from, okay, D by 2 plus D from minus 9Q. Okay, hoping all of you understood the question. Okay, so till we will come with the new question of the chapter electric charges and electric field. Enjoy the question. Do other questions also. Try to solve it. And if there is some difficulty, please ask me. Okay, in the comment section. See you in the next class. Your Asha teacher. This is your Physics Gallery Asha. Okay.